All right, hello everybody. Welcome to Weekly Data Science. My name is Dan Isaza, and today I'm going to be walking you through the a priori algorithm. The a priori algorithm is really good at finding groups of items that co-occur together frequently in a data set. And the reason you might want to do that is that you're looking at some sort of text document and you want to detect something like plagiarism, or you're looking at some genetic information and you want to analyze the occurrence of different biomarkers that occur frequently together, or you're looking at some sort of retail data or shopping data. And that's the scenario that we're going to take a look at today. So let's imagine that you have been hired to analyze shopping data for a large retail store. And in particular, you want to increase their revenue by upselling or cross-selling existing shoppers. And most likely, this is going to have to do with the way in which you design the store. So, where you put items so that people are more likely to buy mustard when they're buying hot dogs, for example. And again, consider the fact that these are physical stores. And so that means that we're going to be faced with different constraints that we would be facing if this were an e-commerce scenario, if we were working for a client like Amazon. So we don't really have the bandwidth to focus on small volume items the way that we would in an online scenario. We want to find groups of items that occur frequently together, and we can't really think about the item that's sold once in a blue moon because we're not going to change our entire store layout just to optimize for those cases where someone buys an item and that happens once every million purchases. So just for today's purposes, let's imagine that we're going to find groups of 3 items that are frequently sold together. And we'll want to define some threshold for what frequently means for us. And in terms of our data set, let's imagine that we're given a file where each line of the file represents a shopping cart at time of checkout. So in this case, bread, diapers, and cheese. That's the contents of a shopping cart at time of checkout. And we can assume that spaces are separating the items in that shopping cart. Okay, so if we're finding the frequent triples in such a data set, the naive approach is to iterate through the entire data set, find all possible groups of 3 items, count up their occurrences, and then see which ones happen more than a particular number of times, more than our threshold for what we consider frequent to be. But there may be a smarter way to do this. So let's say, for example, that here's a quick observation that's going to help us do this more efficiently. Let's say that a set of items A and B is a frequent item set. Every time that the item set AB occurs, the item A is occurring and the item B is occurring. And that may seem like an overly simple observation, but what that allows us to say is that because A and B are each occurring every time that duo is occurring, every time that pair of items is occurring, we know that A and B must each individually be frequently occurring items in order for AB to be a frequent item set. So that means if A is not a frequent item, then we know that the set AB will definitely not be a frequent item set. And by the same virtue, if B is not a frequent item, then AB will definitely not be a frequent item set. So both A and B need to individually be frequent for AB to potentially be frequent. And if A or B is not frequent, then AB will definitely not be frequent. And if we think about item sets with 3 groups, or groups of 3 items rather, like the set ABC, if ABC is a frequent item set, then what does that tell us about the items inside of that set? Go ahead and pause the video here and see if you can figure out what this tells us about the items inside of this set. All right. And you may have figured out that if ABC is a frequent item set, then A and B and C are all frequent items. And the thing that I find really interesting about this too is that the pairs of items inside of that set ABC are also all frequent item sets. So AB and AC and ABC, or sorry, and BC are all frequent item sets as well. So all of these pairs down here, all of these are also frequent item sets. And what that means is that if any of those item sets that we discussed, any of the individual items within ABC are not frequent, then ABC is obviously not frequent. But also, if any of the pairs of items inside of ABC is not frequent, then we know that that triple will definitely not be frequent. So let's say that AB, I just moved this around here. Let's say that the set AB does not occur more than our threshold. Then we know that ABC definitely will not be frequent. And again, keep in mind, there are many more pairs than there are single items, because if you have, let's say that we had 3 items, there are 6 ways that we could combine those. Are there? A, B, A, C, and B, C. No, there are 3 ways that we could combine those. But if we grow the number of if we grow the number of items, then the number of possible pairs increases drastically, and that is even more true for triples, and even more true for groups of 4. And this pattern keeps continuing. And so we don't want to count occurrences of large item sets if we can avoid it. We don't want to spend our computational resources that way. And it's going to be ultimately faster and cheaper for us not to do that. And so in the a priori algorithm, we can make use of that. We're going to make a first pass through the data in which we're going to count all of the occurrences of each item. And then we're going to filter out the items that are not frequent, and we're going to be left with just those frequent items. As we do our second pass through our data, we're going to count the occurrences of the pairs. But actually, here's the thing. We're not going to count all the pairs. We're only going to count candidate pairs. And candidate pairs are pairs where the individual items inside of those pairs occur frequently. And that's going to be a much smaller number of pairs than all possible pairs. So we're already gaining a lot of, we're helping ourselves out here a lot in terms of efficiency. And then we're going to look only for the frequent pairs inside of those candidate pairs. And then again, ignore the miswording here, but instead of counting all the triples, we're only going to count candidate triples. And again, candidate triples are going to be triples where all of the possible item sets that we can make from those 3 items are frequently occurring item sets. Cool. So let's go ahead and take a look at the code for this algorithm. And spoiler alert, we are going to be looking at the code. So if you want to implement this yourself before looking at this, go ahead and do that on your own. I've put up I've put 2 example data sets on GitHub. You can use those to try and implement this algorithm yourself, and then go ahead and come back here and take a look at this code and see what you can learn from it. So here is our data set. Each line, as we discussed, is a shopping cart at time of checkout, and each item they're delimited by spaces, and each item here is one of the items that we'll consider. There are 2 data sets, baskets.txt and other baskets.txt, and you can feel free to browse them and familiarize yourself with them. And so to start, we're going to set our threshold. We're going to set our threshold at 50, for instance, and this is what we consider to make an item set frequent. And then we're going to read in the data, and here's where we're going to count the occurrences of the items. And we're going to take our first pass through the data set. and we're going to read all of the lines from the text file into memory, which is not super efficient, honestly, but for today's purposes, we'll consider that to be okay. And for each of those lines, we're going to split it on white space, and we're going to take each item and we're going to increase its count in our dictionary by 1. And when it's not present, it'll have a count of 0. That's what default dict does for us. And then once we have all of the counts of these candidate items, we're going to filter only for the frequent items. So we have a set of frequent items, and if an item occurs more than our threshold, then we're going to consider it to be a frequent item. So look at how short this code is. It's pretty quick. There are really no checks that we have to see if we're going to filter out a particular item. We're counting every item. Every item is a candidate item in our first pass. So let's contrast that with the second pass through the data. So as we move here to the second pass, we're adding a few things. We're going to add a second default dict to keep track of the counts of the candidate pairs. And we're going to take a second pass through the data. So again, we're going to take each line and split it on white space. And then as we move through, we're going to iterate through this list of items with 2 pointers, essentially. And if the first item is not in our frequent item set, or is not in our set of frequent items, rather, then we're going to move on. So what that looks like in one of these files, let's take this line, for example. We're going to consider toothbrush. And if toothbrush is not a frequently occurring item, then we're going to move on, because we know that any pair that contains toothbrush necessarily cannot be a frequently occurring pair if toothbrush is not a frequent item. So we'll just move on to beer. And let's say that beer is a frequently occurring item. Well, then we'll say, okay, we want to keep track of beer. That's one of the items that we want to keep track of. And then the other items that we'll consider are, toothpaste, and we'll ask is toothpaste a frequently occurring item? And if it's not, then we'll move on to bread, and so on. And so here we're saying, is the first item frequent? If it's not, then let's keep moving through the array with our first index. And once we find a frequent item, then let's create a second index starting at the next item in our list and going all the way through the end. And let's check if that second item that we're considering is frequent. And if it's not frequent, move on to the next possible second item. And once we find a second item that is frequent, then let's create a pair out of those 2 items. And I've written a small helper function called Normalized Group, and it's going to help us make sure that regardless of the order, we consider these items to be the same. And so what Normalized Group is doing, let's jump up there. Here it is. It's just sorting the arguments that we pass in and stringifying them. And so we've got our normalized group as a pair, and now it's a string, and we can use it as the key into this dictionary. And so we can increase the count of that pair by 1. So that's a candidate pair. And we filtered out, look at all of the places where we filtered out possible candidate pairs. And if you look, our code here has gotten quite a bit longer than the initial code for this piece of code. These 4 lines, 3 lines, has now turned into this. It's much larger. Okay, and then once we've gotten all the counts for the candidate pairs, then we can filter out all of the infrequent pairs and look for pairs that only occur more than our threshold. Great. And then once we have all of the frequent pairs, we can move on to do a third pass through the data. And again, look at this pass through the data here where we count the candidate pairs. And now look at the third pass through the data. Without even reading the code, just look at how much code it is. There's so much more. There are so many more cases for us to consider. And at first glance, that may seem cumbersome, but when you look at this, think about all of the opportunities that we have to filter out possible candidate pairs, possible candidate triples rather. We are filtering out so many triples that we're no longer going to have to consider. So let's dive into this. So we're going to take each line in our data set and split it on white space. And then we're going to start with our first pointer the same way that we did here. We're going to consider toothbrush, and then we're going to consider beer, and then toothpaste. And at each step, we're going to ask, is that item a frequently occurring item? And if it's not, we're going to move on. And then we're going to have a second index, and we're going to look for all of the items in front of this one in the list. So let's say that beer is our first frequently occurring item. Then we'll look at toothpaste and bread and cola. And at each of those, we'll ask, is that item frequently occurring? And if it is, then we'll continue to go down through our code here. And if it's not, sorry, that was maybe confusing. The keyword continue is saying we're going to continue through our for loop. So if it is not a frequently occurring item, then this continue statement is going to execute, and we'll keep moving through our for loop. If it is a frequently occurring item, if the second item is a frequently occurring item, then we will consider this first pair that we've encountered. And at this point, we're going to ask, hey, that pair, is it a frequent pair? Because if it's not, then we know that any possible triple that contains that pair is necessarily not a frequently occurring triple. Cool. So let's check if it's a frequent pair. And if it is a frequent pair, then now we can start considering groups of 3 that can be built out of that pair. And so we're going to add a third pointer, a third index, just like this. And so now we'll be considering not just beer and bread, but beer, bread, and cola. Great. And at this point, we'll say, hey, that third item that we're looking at now, is it a frequent item? And if it's not, then this cannot be a frequent triple here. So we'll skip that possible candidate pair altogether. And now let's say that third item is frequent. Then great. We are almost at a candidate pair. But first, don't forget, remember, if ABC is a frequent item set, then all of these pairs inside of ABC, AB, AC, and BC, those are all going to be frequent item sets as well. So we need to make sure that all of those pairs are frequent. So I've written a helper function that generates all possible pairs for us, given a list of items. So we're going to get all of those possible pairs. And if any of those pairs is not a frequent pair, we're going to move on. And if all of those checks up until here pass, that means that we've hit a candidate triple. This triple may be a frequent triple. It's not possible for us at this point to say that will definitely not be a frequent triple. And by the time we get here, we will have ruled out a lot of triples. We will have taken a lot of triples and said, hey, we are just not going to think about these. We're not going to consider them. And that's going to save us a lot of time. And so here we're going to build that candidate triple using this normalized group function that we had before. And we're going to increase the count of it in our count default dict. And then once we have the counts of all of these candidate triples, we are going to filter for only the frequent triples. And if you want to see the function that I wrote for generating pairs, here it is. It's just a set of nested for loops that picks out pairs. Cool. So now we've filtered out for our frequent triples, and then we can view our results. And actually, the way that these data structures worked out, I wanted to filter out the triples directly inside of our triples count default dict. So I'm filtering out the infrequent triples here, and then I'm getting tuples of sorted entries from the list. So this is going to look something like this. It's going to be like A, B, C, and then a count. So each sorted triples is a list of tuples, and every entry in that list looks like this. And so we're going to iterate through the entries, and we're going to print them out like so. And if we run this, here are all of the frequent triples from our data set. So take a look at this. Yeah, we can see that 51 is the lowest count, which makes sense. That's just above our threshold. Yeah, go ahead and browse through this data yourself. I encourage you to take a crack at implementing this algorithm. If you really get stuck, come back and look at this code, but I encourage you to try it on your own. I really think that it's beneficial to implement these algorithms yourself. There are likely standard utilities for just running these algorithms, but I encourage you to implement it yourself because that's the way that you are going to have a deeper understanding of what's going on here. So cool. Yeah, that's about it. I'm going to put some relevant links in the description of this video, including links to the GitHub repository where I've put these data sets for you to play around with. I may try and find some other data sets for you to play with and do the same kind of analysis. And if you've enjoyed this, then like this video, feel free to comment and let me know what you think. Subscribe to this channel if you're interested, and feel free to email me. Feel free to email me your code, email me your thoughts and feedback. Here's my email right here. Yeah, go ahead and email me, and I'm happy to chat. And I have a mailing list that I will put in the description here. Feel free to sign up for that mailing list. And before I leave you, I want to tell you a secret about these data sets. One of these data sets is effectively useless, and I will show you why in my next video. But if you feel so inclined, I want you to take a crack at determining why one of these data sets is entirely useless. And it starts with implementing the Apriori algorithm. But once you've done that, take the results from this algorithm and try and use them to determine how you would increase revenues for this brick and mortar store. Let me know what you find. Feel free to email me, and I will see you next week on Weekly Data Science. Thanks, and take care.